formulas you are getting in that electricity chapter, then we can go with the problems, right? Okay. So first in your electricity chapter, so first you have with charge.
Yeah.
Okay.
Charge.
So how do you define charge?
Charge is basically the coulomb, right? Electrons. The movement of electrons in the circuit is charged, right?
Okay. 1 minute. Okay, so first we'll discuss with electric charge. So electric charge that we have positive and negative charges. So charges, usually we use the formula Q is equals to NE, where N is number of electrons. E. Can you tell me what is the charge of an electron?
1.68.
1.6 into 10 to the power
8?
Yes, 19 coulomb.
Yeah, 19.
1.6 into 10 to the power minus 19 coulomb. So this is the first formula you are getting in electricity chapter. In this charge of an electron, so that is equals to 1.6 into 10 to the power minus 19 coulomb. So in this, what you will get, calculate the number of electrons in 1 coulomb of charge. So just can you note down questions, just whatever I'm telling you, can you write that? Okay. Okay. So then write down or calculate the number of electrons present in 1 coulomb of charge. Number of electrons in charge is 1 coulomb. So how do you calculate here? Q is equals to N into E. Now you are supposed to calculate N. So Q by E. How do you simplify this? 1 by E. E is 1.6 into 10 to the power minus 19. So can you tell me what is the answer for this?
6.2.
Simplification.
6.24 or 8 into the power 10 to the into 10 to the power 18.
Yes. So 6.25 into 10 to the power 18 electrons. So this calculations, I think you are perfect with the calculations. Are you perfect with the calculations?
Yeah.
Okay. So the next one more question. It takes 2 seconds for a charge of 4 coulomb to flow in a circuit. Time is 2 seconds. Charge is 4 coulomb. You should calculate the current.
4 coulomb.
Charge is 4 coulomb. You should calculate the current.
Two ampere.
Okay, 2 ampere. So before going that, I think I should have told you about current. So current, how you define current?
I is equal to
current
Q
is
by
equal
Q by time.
T. Okay. Okay, coulomb by time, or it is also SI unit of current. Coulomb
Ampere.
per second, right? Ampere. So you take it as Q by T means that you are writing charge is given 4 coulombs and time is 2 seconds. So current will be 2 amperes. Okay? Right.
Yeah.
The next one more question. An electric bulb draws a current of 0.25 amperes. Current is given 0.25 amperes. An electric bulb draws a current of 0.25 amperes for 20 minutes. Time is given 20 minutes.
Okay.
Current is 0.25 amperes. Time is 20 minutes. Calculate the amount of charge that flows through the circuit.
So you have to convert minutes to seconds. So it will be 12,000 seconds. Then
calculate the charge.
Equal to I into T. So 0.5 into 12. 100 gives
Q is equals to I into T. So this you are converting into 20 into 60. So you get this as 1200 seconds.
300.
So,
300.
okay. So
300.
0.25 into 1200 if you do, then you'll get 300 coulomb. 300 coulomb of charge is done. Okay, right. The next one, I think this you can do it just for practice purpose. I'll give this question. You can do it later. Okay. Current is 4 amperes. Current is 4 amperes, and the time is 10 seconds. You should calculate the amount of charge in this. Okay. Then next one, charge is 10 coulomb, and time is 2 seconds. Time is 2 seconds. Calculate the amount of. Hello. Are you able to hear me?
Yeah. Charges.
Charge is 10 coulomb.
Okay.
And time is 2 seconds. And you should calculate the current flowing through it. Okay. So that these two problems you can do it later. Next we'll discuss with the electric potential. So electric potential. How do you define this electric potential?
The work done for an charge to move from between 2 points of a charge.
2 points. Okay. So work done by charge. So W by Q. You represent that as W by Q. Okay. So based on this problems, so just one write down. A charge of 6 coulomb flows through a copper wire for 2 seconds. A charge of 6 coulombs flows through a copper wire for a charge of 6 coulomb flow through a copper wire for 2 seconds, connected across cell of potential difference 25 volt. Charge is given 6 coulomb, current time is given 2 seconds, and potential difference is given 25 volt. So you should calculate the amount of work done.
Okay.
How do you do this?
is equal to W,
Work
which is
done.
by V into Q.
Yes, V into Q. So V is 25, Q is given 6. So what will be our answer?
If 150.
Yes, 150 joules. So 150 joules of work is done. Okay, then next question. In an electric circuit, work done of 100 joules. Work done is given 100 joules is required to maintain a potential difference of 12 volt. To maintain a potential difference of 12 volt for 5 seconds. Time is given 5 seconds.
Okay.
Calculate the current flowing through the conductor. You should calculate I. Work done is given 100 joules. Potential difference is 12 volt. Time is 5 seconds. And calculate I. So what you will do first here?
First we have to find coulomb. So we have to.
Yes. So work done.
W by V.
V is equals to W by Q. Or Q is equals to what you write? Q is equals to W by V. So Q what you get? Q is 100 by V is 12. Now you got charge and you should calculate current.
Yeah.
Current, how do you calculate? I is equals to Q by T. Okay, so Q by T means what you get? I is equals to Q is 100 by 12 into 1 by 3. Sorry, time 5 seconds. Okay.
Yeah.
1 by 5. So 1 by 5 means what is the answer?
5 by 3, so 3.
Okay. So 5 by 3 if you have got, okay, well, that is 1 point, okay, 1.66 you'll get, that is rounded off to 1.7 ampere. 1.7 ampere. Okay. The next one, find the potential difference across the terminals of a copper wire if charge is 4 coulomb, performs a work of 200 joules. You should calculate here potential difference. Charge is given 4 coulomb, work is done 200 joules. You should calculate the potential difference. So what is the formula you are using? V is equals to W by Q. So W is 200, by charge is 4. So what you get?
50
volt. Yes, 50 volt. Okay, so same way next. Shall I give you some problems that you can practice that later on? Just given things I'll write that you can work. Okay. So just to write down the question. Charge is 150 coulomb. Charge is 150 coulomb, and time is 1 minute. Time is 1 minute. You should calculate current flowing through it. Are you able to see that the whiteboard I'm using?
Yeah.
Okay. So this charge is 150 coulomb. Time is 1 minute. Calculate the current flowing through it. Okay. The next question.
Okay.
Next question. Potential difference you should calculate. Calculate the potential difference between the 2 points where work done is 100 joules. 100 joules of work is done to transfer charge of 20 coulombs. To transfer charge of 20 coulombs. Okay. Then next one, calculate the amount of work done. Calculate the amount of work done in moving a charge of 2 coulomb. Moving a charge of 2 coulomb across a potential difference of 12 volt.
Okay.
Across a potential difference of 12 volts. Okay. The next one, calculate the amount of work done in shifting a charge of 2 coulombs. Shifting a charge of 2 coulombs from point A to point B. From point A to point B, having potentials VA is 110 volt and VB, potential at point B, is 25 volt. So how do you do this? VA and VB when potentials are given. When directly they have not given the potential. So here they have given VA and VB. Then how do you calculate that? Potential difference you should calculate here. So potential difference we write it as VA minus VB. So VA minus VB is 110 volt minus 25 volt. This what you get, that you should take it as potential difference and you should calculate the amount of work done. Okay?
Okay.
Understood this one? Okay.
Yeah.
Then if current through a lamp is 5 amperes, fifth question, current through the lamp is 5 amperes, what is the charge passing through it in 10 seconds? What is the charge passing through it in 10 seconds?
Okay.
Okay. The next question, the amount of electric charge passing through a conductor in 10 minutes. Time is given 10 minutes and work charges can you just repeat the question? What you have written?
Calculate the electric charge passing through a circuit in time 10 minutes. And
10 minutes. Current is 5 amperes. Current is 5 amperes.
okay.
Okay. So these questions you just practice based on two formulas. So that is, one is charge, that is Q is equals to N into E, and I is equals to Q by T, and V is equals to W by Q. Using these three formulas only you should do this problem. Okay? I understood now?
Yeah.
Shall I move on to the next topic?
Yeah.
So in this one more you should remember current. For measuring current, what is the device you are using?
Ammeter
Ammeter. And how it is connected?
in series.
In series. And what is the resistance of an ideal ammeter?
It should be very low resistance.
Very low. So very low resistance. Very low resistances, you can take it as 0 ohms also you can take it. Okay, then how voltage is measured? Voltage or potential difference?
Through voltmeter.
Voltmeter. And how it is connected?
It's connected in parallel.
Parallel. And what is what is the resistance of an ideal voltmeter?
High resistance.
So very high means it should have infinite resistance. Infinite resistance. Okay, so that is also once they have asked what is the resistance of an ideal voltmeter. So that is infinite resistance. Infinite ohms you should write. Okay. Okay. Then next we'll move on with the next formula so that we are getting with Ohm's law. Okay. So Ohm's law, I think circuit, you are clear with the circuit. What are the components you get in Ohm's law circuit? So one is you are connecting ammeter in series, then you are taking one resistance, then you are connecting one voltmeter, that is should be in parallel, then it is connected to a battery, then a key. Here this rheostat is optional. So resistance, current is measured using ammeter, potential difference is measured using voltmeter. So in this way you are going to get the Ohm's law circuit. Okay. So what is the statement for this Ohm's law?
The electric current is directly proportional to the potential difference across 2 points in a conductor.
Yes.
Given that the temperature remains constant.
At the constant temperature, you get potential differences directly proportional to current. Potential difference is directly proportional to current, or you write it as V is equals to I into R. So this is just one triangle trick you can remember. So just write V in the top and IR here. Then using this you can remember the formula. So if you are calculating potential difference V, then you will take it as the product of I into R. If you are calculating I current, then you can take it as V by R. And if you are calculating resistance, then you can take it as V by I. Okay, so these three formulas you will get in one relation. So that is Ohm's law relation. Okay.
Okay.
So here, based on this, V is equals to I into R. So just will solve some problems. The potential difference between the 2 points is 0.1 volt. V is equals to 0.1 volt. And current flowing through it is 2 ampere. Calculate the resistance. Potential difference between 2 points is 0.1 volt. Current is 2 ampere. Calculate the resistance between the 2 points. So what formula you are using here? R is equals to V by I. So V is 0.1 by 2. Simplify this, 0.1 by 2. What you get?
0.05.
0.05 ohm. Yes, 0.05 ohm. Okay. Resistance of the conductor is 0.05 ohm. Okay. The next question. A simple electric circuit has a 24 volt battery. Battery is given 24 volts. And a resistor of 60 ohms is connected. 60 ohms is connected. What will be the current in the circuit? Potential difference of 24 volts, resistor of 50 ohms is connected. What will be the current in the circuit? I is equals to V by R. V is given 24, R is given 60. So what you get current?
Mm, mm, 0.67.
0. Do calculations correctly. Do calculations correctly. See here, 6 4s are 24, 6 10s are 60. So 4 by 10 means you can directly write it as 0.4 ampere. Okay?
Okay.
Next question. An electric iron draws a current of 3.4 ampere from the 220 volt supply line. An electric iron draws a current of 3.4 amperes from a 220 volt supply line. Current is given 3.4 amperes. Potential difference that is given 220 volt. Then you should calculate what current will this electric iron draw when it is connected to 110 volt supply line. What will be the current if potential difference is changed to 110 volt? So in this case, when you, what you should do first?
First, resistance of the wire we have to find.
Yeah, yes. Find out the resistance of the wire first. So resistance of the wire, what you get here? R is equals to V by I. So V by I is 220 by 3.4. 220 by 3.4. Then you can calculate I. I is equals to V by R. So V is 110. R will be the reciprocal of this. So reciprocal of this means you will be getting 220 into 3.4. So if you do the calculation, 7 1 2 2 1 1.4. Are you getting 1.7 ampere current? See, in calculating resistance, don't simplify up to the least value, because here in this question we are not supposed to calculate the resistance. So if you go on doing cancellation and calculating the resistance, then that will be waste of your time. So just you should observe whether the given numbers are able to cancel in the next question or not, next part of the question. Then you should keep it as it is and do the calculation. Okay?
Okay.
Understood this question?
Yeah.
Okay. So then do next question. Resistance of the conductor is 3 ohms. Resistance of the conductor is 3 ohms. Potential difference is 6 volts. Calculate the current.
3 ampere.
Yeah.
No,
3
sorry.
ohms.
2 ampere. 2 ampere.
Yeah, it's 2 amperes. So what is the formula you're using? I is equal to V by R. So that is 6 by 3. So that is equal to 2 amperes. Okay. Right. So next question. A car headlight bulb working on a 12-volt car battery. A car headlight bulb is working on a 12-volt car battery, draws a current of 0.5 amperes. A car headlight bulb working on a 12-volt car battery draws a current of 0.5 amperes. Calculate the resistance of the bulb. Calculate the resistance of the bulb. Or you should calculate. How you do this? Formula R is equals to V by I. Yeah. 12 by 0.5. So what you get the answer? It is 24 ohms. 24 ohms. Okay. Then resistance is 24. Potential difference is 230 volts. Calculate the current. Resistance is 25 ohms. Potential difference is 230 volts. Calculate the electric current. Are you able to do this? I is equals to V by R.
9.2.
230 by 25. 230 by 25. What you get? Answer?
9.2 ampere.
Yeah, 9.2 amperes. Okay. Then next question. Okay, so next one we'll do with the resistance of the conductor. So resistance, how you define resistance of a conductor? Resistance of a conductor
is a constant given for current for a conductor.
So resistance, how you define that resistance? What is the actual function of this resistance if you take in a conductor?
Like the opposition force against the current.
So it is the property of a conductor. Resistance is the property of a conductor which opposes the flow of electrons. Okay? Which opposes the flow of electrons. Opposes flow of electrons in conductor. Okay? So now in this, one formula you will be using from Ohm's law. So that is R is equals to V by I. So this formula you should use when potential difference and current are given. You'll be getting resistance formulas in different manners. So you should use this formula R is equals to V by I when you are given with potential difference and current. Okay. Then next one, one more relation you have for resistance. So that is R is equal to rho into L by A. Now what is the relation between R, rho, L and A?
Rho is the resistivity of the conductor.
Okay.
Length of the conductor and cross-sectional area of the...
Yeah, a cross-sectional area. And what is the relation? R and L, how they are related?
Proportional to L, and R is inversely proportional to area.
Of the conductor and inversely proportional to area of cross-section. So the question, based on this Suppose here length of the conductor is given 2 meter. Length of the conductor is given 2 meter, and area of cross section is given 1.7 into 10 to the power minus 6 square meter. Length of the conductor is given 2 meter. Area of cross section is given 1.7 into 10 to the power minus 6 square meter.
Okay.
Has a resistance of 2 into 10 to the power minus 2 ohm. Has a resistance of 2 into 10 to the power minus 2 ohms. Calculate the resistivity, rho value. Length is given 2 meter. Area of cross section is given 1.7 into 10 to the power minus 6 square meter, and has a resistance of 2 into 10 to the power minus 2 ohms.
1.7 into 10 to the power minus 8.
Yeah. So how you calculate this? Rho is equals to R into A by L. So R is 2 into 10 to the power minus 2, and area of cross section is 1.7 into 10 to the power minus 6 divided by 2. So here if you cancel this 2, then you will be getting 1.7 into 10 to the power minus 8. What is the unit here you are using?
Ohm meter.
Yeah, ohm meter. Right. So now this is when you are calculating resistivity. Okay. The next one, resistance, a 6 ohm resistance wire. A 6 ohm resistance wire is doubled up by folding. Calculate new resistance of the wire. Calculate the new resistance of the wire. Doubled up by folding. So when you are folding that, if length L1 is L, then L2 will become half of it.
Yeah.
And area of cross section, if A1 is A, then when it is doubled by folding, then A2 will become 2 times of A. Then how do you calculate R2 here? R1 is 6 ohms, you should calculate R2. What is the relation we have? R is directly proportional to L by A. Now R1 by R2 is equals to L1 by A1 into this. When you are taking reciprocal, you will get it as A2 by L2. L1 by A1 into A2 by L2, reciprocal. Then substitute the values given and calculate what will be the value of R2.
$1.5.
Yeah, it is 1.5 ohm. 1.5 ohm. Okay. Now value R2 you will get it as 1.5 ohm. Okay. Then next question. In this case, length is given 1 meter. Length of the conductor is 1 meter, and diameter of the conductor is 0.222 millimeter. Length of the conductor is 1 meter. Diameter of the conductor is 0.2 millimeter. Resistance of the conductor is 10 ohms. Resistance of the conductor is 10 ohms. Calculate the resistivity. See here, diameter is given. So first step, when diameter of the wire is given, you should calculate its radius. So if diameter is 0.2 millimeter, what will be its radius?
0.1 millimeter.
0.1 millimeter. How you write millimeter?
100 into 10.
10 to the power for milli. What you get? 10 to the power minus 3.
3, right? Yeah,
Okay.
okay.
10 to the power minus 3 meter. Okay. Now radius is given. You should calculate area of cross section. What will be the area of cross section for the wire? What will be the shape of that wire? Area of cross section. What area you should take there?
It's a pi r square. 3.
What formula you will use here to calculate area of cross section?
Pi r square.
Yeah, pi r square. So pi value you can take it as 3.14. And r value is given 0.1 into 10 to the power minus 3 whole square. So this, if you simplify, you'll get area of cross section. So area of cross section, after getting area of cross section, yes, I'm not able to. 3.14 into 10 to the power
10 to the power minus 3. Sorry, minus 2.
Here, within the brackets, you have
4.
See, so here within the brackets you have 0.1 into 10 to the power minus 3. So this total you can take it as minus 4.
Yeah, minus 4. I told minus 4.
So minus 4 square. So if it's square you are taking, then it will be
4 square. Okay.
3.14 into 10 to the power minus
8.
8. Minus 8 square meter.
Okay.
So now 3.14 into 10 to the power minus 8 square meter means you will be getting resistivity, rho.
Yeah.
Rho is equals to
10 into 3.14 into 10 to the power minus 8 divided by 1.
R into A by L.
3.14 into 10 to the power minus 7.
Minus 7. Okay, so that is 7 units. Unit.
Ohm meter.
Yeah, it's ohm meter. So it is 3.14 into 10 to the power minus 7 ohm meter you'll be getting. Okay. So the next one. So just I'll give you the questions and you can try with this. So I think you got to know how to calculate this resistivity and resistance. Okay, shall I give you the questions?
Sure.
Or do you want me to solve some more problems?
No, like word problem types are there, ma'am. Word problem, like those big 5 marks or 4 marks type. Sorry, 3 marks.
Like series and parallel.
Yeah, like the
series.
The 5 marks and 3 marks worth questions they'll give. Word problems or like hot type of questions.
Okay. So then just write down the question. This will be in series, we'll take that. So resistance in series, you take it as sum of the resistances, R1, R2, so up to infinite, you can take the number of. And resistance in parallel, how you write? 1 by Rp is equals to 1 by R1 plus 1 by R2. So this formula you'll be using to calculate resistance in series and in parallel. Okay? Yeah. Okay. So here, when you are taking the series, in series combination, resistance will increase. And in parallel combination, resistance will decrease. Okay?
Minimum and maximum resistance.
Minimum and maximum. So maximum resistance you'll be getting in series and minimum resistance you'll be getting in parallel. Okay. Here, in resistance in series, when you are taking, if an electric bulb of resistance 20 ohms, an electric bulb of resistance 20 ohms and a resistance wire of 4 ohms, resistance of bulb is 20 ohms and resistance of wire is 4 ohms. They are connected in series. They are connected in series with a 6-volt battery. With a 6-volt battery, calculate first one, total resistance in the circuit. Total resistance in the circuit. Second one, current in the circuit. Calculate total resistance in the circuit. Second question, current in the circuit. And third question, potential difference across the bulb. And fourth question, potential difference across the resistance wire. So this is a 5 marks type question.
And
Total resistance
across the last one?
Across wire.
Okay.
So how do you calculate the total resistance in the circuit?
R1 plus R2.
They are connected in series. They are connected in series.
Yeah.
They are connected in series. Total resistance will be R will be equal to resistance of bulb plus resistance of wire. That is 20 plus 4. You get it as 24 ohms.
Yeah.
Right? Now they have asked you to calculate the current in the circuit. How you calculate the current in the circuit?
V is equal to IR, so I is equal to V by R. RS in this case.
So what you get answer? I is equals to V by R. V is given. V is given 6 volt. And R is, you got it as 24 ohms.
1 by 4.
So what will be the current in the 0.25
ampere?
0.25 is the 25 ampere. Okay, now you should calculate the potential difference across the bulb.
Yeah, okay.
Potential difference across the bulb.
I is 0.25 into R20. So 50. 5
volt. Yeah. Now calculate the potential difference across resistance wire.
into 4. 1 volt.
No. Potential difference across the resistance wire.
Yeah, 4 into 2, 0.25.
4 into, okay. 4 into 0.25, you are getting that as 1 volt.
1 volt, yeah.
1 volt, okay. Then next one, a battery of 9 volt is connected. A battery of 9 volt is connected in series with the resistor. In series with the resistor of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms, and 12 ohms. A battery of 9 volt is connected in series with the resistors of 0.2 ohms, 0.3 ohms, 0.4, 0.5, and 12 ohms.
Okay.
How much current would flow through 12 ohm resistor? How much current would flow through 12 ohm resistor? So what you should do in this? Current through 12 ohm resistor you should calculate.
V into
Potential
IR.
difference is given. What will be the resistance?
R is 12.
Here, all the resistors are connected in series. So you should take the equivalent resistance of the circuit. So equivalent resistance of the circuit will be 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12 ohms. That will be
0.15 plus 12. 12.15.
12.15. No, calculate first resistance correctly. 0.2 plus 0.3, 0.5. So that will be 1. So that will be 13.4. 13.4. 13.4 ohms.
1.4.
Okay. 13.4 ohms. Now calculate current. Calculate current.
Okay.
Current is V by R.
9 by 13.4.
What you get the answer?
This is
9 by 13.4. 9 by 13.4. What you get? So I'll get it around 0.67 amperes.
Yeah.
Ampere.
0.67.
Okay. Yeah, 0.67 amperes. Okay. So, okay. Then next one. Question is, potential difference of 4 volt is applied. Potential difference of 4 volts is applied for a circuit in which resistances R1 6 ohms and R2 2 ohms are connected in series. They are connected in series.
Okay.
Then you should calculate the equivalent resistance and current, equivalent resistance and current in the circuit, and also potential difference across 6 ohm resistance. Potential difference across 6 ohm resistance.
Okay.
Yeah, do it. So here equivalent resistance you are getting R1 plus R2, so that is equals to 6 plus
And
2.
then current is 1.5 ampere. Across
Current is V by R,
yeah,
4
that
by
is
8.
0.5.
So that is 0.5 amperes. And potential difference across 6 ohms. V is
No,
equals
current
to,
we have to find the
it is in connected in series.
4. It's 4. Okay, okay. I thought 12 was the 4.
No, no. Okay. 6 plus 2, equivalent resistance you are going to take.
Okay. V is equal to IR. So V is equal to 0.5 into 6.
V is equals to IR.
3 volt.
So it is 0.5 into 6. So you get it 3 volts. Okay. So this short questions, whatever I'm giving, so that in combinedly you will be getting in 5 marks or 4 marks questions. Okay.
Okay.
So next question. The resistance of a conductor is 27 ohm. The resistance of a conductor is 27 ohm. Is cut into 3 equal parts. Is cut into 3 equal parts and connected in parallel. It is cut into 3 equal parts and connected in parallel. Then calculate the equivalent resistance of this combination. Calculate the equivalent resistance of this combination. So when it is cut into 3 equal parts, what you are getting the resistance in each part?
Will increase by 3 times.
Sorry, your voice is breaking. I'm not able to hear
Length
properly.
will increase. Length will decrease by 3 and area will
Resistance?
increase by 3.
No, if there is no change in area, you are just cutting that wire. So there is no change in area. So length only will decrease. So if length is decreasing, then what will be the resistance? Resistance also will decrease.
Okay.
So resistance, if L you are cutting into 3 equal parts, means then resistance of each part will be R by 3.
Okay, so R is equal to 27 times. So 1 by 3 means 9. 9.
So that 9, you are connecting that 9 ohm resistor in parallel.
Yeah.
First, you are taking that 3 resistors. This will be R by 3, R by 3, R by 3. So 1 R by 3 will be equal to 27 by 3. So that will be equal to 9 ohms. Now 9 ohms you are connecting in parallel. We will get it as 1 by 9 plus 1 by 9 plus 1 by 9. So that will be equal to 3 by 9. So what will be the equivalent resistance?
3.
3 ones are 3 threes are. So you will get it as equivalent resistance will be 3 ohms. Okay?
Okay.
Okay. Then next one, 3 resistances. 4 ohms, 5 ohms, and 20 ohms are connected in parallel. 4 ohms, 5 ohms, and 20 ohms are connected in parallel. Calculate their combined resistance. Calculate their combined resistance.
Zero 0.5.
0.5 I is getting 1 by 4 plus 1 by 5 plus 1 by 20.
So 5 plus 5, 10. 10 by 20. 1 by 10. 0.
10 by 20. So 1 by R is equals to, we are getting 1 by 2. So equivalent resistance will be 2 ohms.
2.
Yeah, 2 ohms. Okay. Yeah. So then next one, in the given circuit, this is the circuit, 6 ohms, here it is 2 ohms, and here it is 6 ohms. Calculate the combined resistance. First two resistors are in parallel, third resistor is in series.
Okay.
So calculate the combined resistance.
Okay. Equivalent is 7.5 ohm.
Equivalent is? Yeah, 7.5 ohms. Okay. Next, one more. Same figure. Just you take it as R1 and R2 and R3. Just you can do this later on. R1 is 25 ohms. R1 is 25 ohms. R2 is 15 ohms. And R3 is 40 ohms. Okay. And next one, in the next case, R1, R2, R3. All three are 6 ohms.
Or 6 ohm.
These two problems. All three are equal. That is equal to 6 ohms. Okay.
Okay.
Then next one, I'm going to draw the circuit. So here, this is 2-volt battery. You are connecting here 1 ohm resistance, and here 2 ohm resistance, and here 3 ohm resistance. 1, 2, and 3. Okay. You should calculate the potential difference across 3 ohm resistors. Potential difference across 3 ohm resistance.
Okay.
Yeah, do it. First, what you will calculate in this?
Current.
To calculate current, you need equivalent resistance.
Yeah.
So, what is the equivalent resistance of circuit?
6.
Yeah, 6 ohms. And current will be V by R. Now, you are supposed to calculate the potential difference across 3 ohms.
Yeah.
Potential difference across 3. Potential difference across 3 ohms resistance. What is the formula you are using here? V is equals to?
V is equal to IR. So
IR.
is
So I you got it 1 by 3. And R they have given question across 3 ohm resistor. So what will be the potential difference?
1 volt.
So it is 1 volt. Okay.
Yeah.
So one more question. 3 resistors are connected in the shape of a triangle. This is 2 ohms, and here it is 2 ohms, and here it is 4 ohms. Calculate the equivalent resistance. How to calculate the equivalent resistance in this case?
2 and 2 are connected in series.
Yeah. So you'll get that equivalent as,
Parallel with it.
yeah. Then you'll get it as 1 by 4 plus 1 by 4.
4 ohms. So
That will be equal to,
2
so
by
this is
4.
2 plus 2.
So
That is 4 ohms. Now 1 by 4 plus 1 by 4.
2 ohms.
That will be 2 by 4. So equivalent resistance in this case will be
2.
2. Okay?
Yeah.
Yeah. The next one. Uh, resistors are connected. All are 10 ohm resistors. This is connected in the middle. 4 are 10 ohms resistors only. They are connected to a battery of 3 volt. Okay? It is connected to a battery of 3 volt. You should calculate the equivalent resistance and also current flowing through the circuit.
Can you tell the what is the ohm?
10 ohms.
All.
10 ohms. All 4 are equal. All 4 are equal. 10 ohms. Line that is joined in the middle. Oh, one more. I will draw that once again. This line is joined. 4 resistors are there. 1 and this side 1. Here 1 and here 1. 4 resistors. It is joined to a 3 volt battery. All are 10 ohms.
Okay.
Now you should calculate 3 volt battery. Calculate equivalent resistance and current through the circuit.
Okay. Equivalent is 10 ohm.
Yeah, equivalent is 10 ohm.
What the find? Current.
Current.
I will use 0.3 ampere.
Yeah, 0.3 ohm. So equivalent resistance, getting it as 10 ohms and current is 0.3 amperes. Okay. Okay.
Yeah.
One minute. I should start with new whiteboard. 25 slides finished here. 1 minute. I will restart this. One minute. So I'll just this PD. I think 25 slides are finished. So again, I should start this new whiteboard sheet. So I'll just stop this and again I'll restart it. Okay.
Okay.
Huh. Okay. Okay. So here, electric power, last one topic in this chapter, Joule's law of heating effect. So based on that also you'll be getting questions. So shall we do that? Joule's law of heating effect. Okay. So in this Joule's law of heating effect, so what is the formula you're using for Joule's law of heating effect? What is the
I square RT.
Yeah. Energy, that is heat energy, is given by H is equals to I square R T, where I is current, R is resistance, and T is the time for which that electric appliance is used. And in this energy you are calculating, one more formula what you will use for to calculate the electrical energy. So that is electric power. Electric power. So what formula you are using to calculate power is equals to
VI.
P is equals to V into I. This is one formula you are using. Still, P is equals to, in terms of energy, amount of energy consumed per unit time. So E by T.
Yeah.
And one more formula, if you use just in place of E, I square R.
Q by T, another.
Yeah. So that is one more formula you can use here. I square R or V square by R. Okay. So these formulas you'll be using. And based on this, we'll solve some problems now. So, a refrigerator having a rating of 350 watts. Refrigerator having a power rating of 350 watts. Power is given 350 watts. Operates for 10 hours a day. Time is given 10 hours. Calculate the cost of electrical energy to operate it for a month of 30 days. The rate of electrical energy is given. Rate is given rupees 3.40 per unit. You should calculate the cost of using that refrigerator for 1 month. So this is 4 marks question. Energy you should calculate first. Power is given in terms of watt. So unit of energy you should always write it in kilowatt hour. So when you are taking in kilowatt, you should first convert power in terms of kilowatt. Power is given in terms of watt. How you will convert that in terms of kilowatt? 350 watts. To convert that in terms of kilowatts, what you should do?
0.35.
Yeah, 0.35 kilowatts. So if you are dividing that by 1000, so 0.35 kilowatt. Now you got power. You should calculate the energy. Electrical energy. Electrical energy is power into time. So power is 3.35 into time is given
3.5.
Divide by 1000 we are doing.
3.5.
Divide by 1000 when you are doing. So you are just calculating 0.35 will get. 0 gets cancelled. 35 by 100. So that is equals to 0.35 kilowatt. Not 3.5. 350 by 1000 we are doing to convert that in terms of kilowatt. Okay. So now you should calculate energy. Energy is equals to power into time. Time is given for 10 hours. So 0.35 into 10. So you'll get that as 3.5 kilowatt hour. 3.5 kilowatt hour. This is for 1 day. 1 day consumption of energy is 3.5 kilowatt hour. But it is given for 30 days. For 30 days, this is for 1 day. For 30 days,
3.5 into 30.
3.5 into 30.
3.4.
Yeah, so that is total, you'll calculate the cost. So into 3, this you'll get it as around 1.5 kilowatt hour for 1 hour or 1 month. Then cost you will get it as total 105 into 3.4. 105 into 3.4. So that is rupees rupees 357 you will get.
357.
Yeah, 357. Okay, 350. Cost of using that refrigerator 1 month is 357. Okay, yeah. The next one, a bulb is rated 200 volt. Bulb is rated 200 volt. For power is 100 watt. Power is 100 watt. What is the resistance of 5 such bulbs for 4 hours? 5 such bulbs burn 4 hours. Number of bulbs are given 5 bulbs. You are running that bulb for 4 hours. So you should calculate the resistance.
Okay.
So what you get the resistance value?
P is equal to V into I.
P is equals to V square by R you can use.
Okay.
P is equals to V square by R. So P is equals to V square by R. So V is given 200 volts. R is equals to V square by P. So R is equals to V square is 200 into 200 by P, 100. So you get it as
400
resistance 400 ohms.
ohm.
400 ohms. Okay. So now power is given in terms of watt. You should convert that in terms of kilowatt hour.
Okay.
100 watt, if you are converting that in terms of kilowatt hour, kilowatt, what you get?
100 watt into kilowatt means 0.1.
Yeah, 0.1 power will be 0.1 kilowatt. Now you should calculate energy. Energy is equals to P into T. Power is 0.1. Time is given, it is used for 4 hours. And how many bulbs are given? 5 bulbs. So total energy consumed will be 2 kilowatt hour. 5 4 are 20. 20 into 0.1. So you get 2 kilowatt hour. Yeah.
Oh.
So now 1 unit is rupees 4.6. 1 unit is 4.6. What is the cost of using that 5? 9.2
rupees.
Yeah, 9.2 rupees. Okay. So the next question. An electric heater draws a current of 10 amperes. An electric heater draws a current of 10 amperes from a 220 volt supply. An electric heater draws a current of 10 amperes from a 220 volt supply. What is the cost of using the heater for 5 hours every day? 5 hours every day for 30 days. For 30 days, if the cost of 1 unit is rupees 5.2.
Okay.
Do it. First calculate power. I is given, V is given. What is the formula you are using to calculate power?
Right.
E is equals to V into I. Okay. P is equals to V into I means you'll get 10 into 220. So that will be equal to 2.2 kilowatt. We are converting that in terms of kilowatts, right? Now energy you should calculate P into T. So that is 2.2 into time is given 5 hours a day. 2.2 into 5. That is equals to 11 kilowatt hour you are getting. This is per day. 11 kilowatt hour per day. They have asked here for 30 days. Energy consumed for 30 days.
kilowatt-hours.
Okay, so for 30 days you get it as 11 into 30. So that is equals to 330 kilowatt hour. So 1 unit is 5.2. What will be the cost, total cost? 330 units. 1 unit is 5.2. Okay.
1,760.
Yeah, it is cost is rupees 1,716. 1,716. Okay.
Yeah.
So I think you can. Is it clear with this problem?
Yeah. Yeah.
Okay. Still, do you have any doubts in this?
No.
Okay. So I think electricity chapter you can solve now problem.
Yeah.
Okay. So I think already it's 9:20. Let's time up. Then magnetic effects chapter I can think we can do it in the next.
Ma'am, good evening.
Today evening. Okay. So in magnetic effects chapter, you don't have any numerical. So that is based on application-based questions you will be getting in that magnetic effects chapter. Okay. So in that chapter, how you want me to clear your doubts in that?
That like the 2, 3, 5 marks questions I wanted that to get clear, including
Oh,
MCQs.
okay. So, okay. MCQs and that previous year questions we can discuss, I think.
Yeah.
Okay. So that we'll do in the evening. Evening I'll inform the timings. Okay.
Okay.
I think electricity chapter, if you have any doubts, you just go through that. This whatever the problems we have done here, this PDF will be available in that TeachMint app only.
Okay.
Recording and PDF both will be available. You can just go through that one if you have any doubts in that. If you have any doubts, I'll clear it in the evening. Okay.
Okay.
Okay. Done.
Thank you, ma'am.
Okay.